Multiple choice questions. Question 1. Which statement about molecules in a gas is correct? At fixed temperature, they all move at the same speed. That is absolutely false, because if they all moved at the same speed, what would be the point of the Maxwell-Boltzmann curve? At fixed temperature, the average kinetic energy is constant. That is true. And the rest, obviously, false. Question 2. Consider the change that occurs in the shape of the curve for the distribution of molecular energies in the gas when the temperature of the gas is increased, which is a correct statement about the gas molecules at a high temperature. There are more molecules with any given energy. False. There are more molecules with the mean energy. No. There are more molecules with most probable energy. Yes, most probable energy, remember, is most common energy. So if you are increasing the temperature, higher temperature, there are going to be more molecules with the most common energy. Question 4. This question is about the Maxwell-Boltzmann distribution of molecular energies in a sample of gas shown in the following figure. What does the area under the curve represent? A. The total energy of the particles. No, we should know that it is B. Clearly, the total number of particles. The total number of particles, the number of particles that can react with each other, that is above here. And total number of particles that have activation energy, yeah. The answer is B. Question 5. The graph below shows a typical energy distribution of particles of an ideal gas in the sealed container at a fixed temperature. Which of the following statements is true? Position A represents the mean energy of a molecule in the container. No, that is clearly, it's not extremely clear, but that is the most probable energy. The mean is always slightly to the right to the most probable energy, so the mean would probably be somewhere here, not there. So A is wrong. Addition of a catalyst moves the position of EA to the right. This one's a bit of a trick question, but if you are very confident with the Maxwell-Boltzmann curve, you should understand that this is completely wrong. Because if we add a catalyst, what does the catalyst do? It provides alternative pathway with a lower activation energy, right? So what would happen is that if you add a catalyst, the position would move to the left, not to the right, because to the right is where there's more energy needed. So it's not B. C. The area under the curve to the right of EA represents the number of molecules with enough energy to react. Yes, that is absolutely true, and therefore D is false. Question 8. The experiment was repeated at 20 degrees Celsius using 250 centimeters cubed conical flask. Which statement is correct about the time taken for the crust to disappear when using the large conical flask? Time taken will not be affected by using a large conical flask. That's absolutely false. It is impossible to predict how the time taken will be affected by using a large conical flask. No. So it's either B or C. Time taken will be decreased by using the large conical flask. That does not make any sense. If we have a larger conical flask, the time clearly would be increased by the time taken for the crust to disappear. Yeah, the time clearly would be increased because it's a large conical flask, and the crust, let's say the crust is tiny here, but if I have another conical flask, but that's a bit way smaller, time taken for the crust to disappear in the bigger one, a large conical flask, is going to be increased. So the answer is C. Which line shows how the volume of hydrogen produced changes with time? An excess of magnesium reacts with hydrochloric acid to form hydrogen gas. Okay. Line X on the graph shows how the volume of hydrogen produced changes with time as magnesium reacts with 30 centimeters cubed of 1.0 moles per dm minus cubed hydrochloric acid. The reaction was repeated using 20 centimeters cubed of 2.0 moles per dm minus cubed hydrochloric acid with all other conditions the same. Which line shows how the volume of hydrogen produced changes with time? So this kind of question, what we have to do is they've given us a concentration, they've given us a volume, most common thing to do is find out the moles, and that's what we're going to do. Moles is concentration times by volume. So in this case, it's going to be 30. Obviously, we need to divide it by 1,000 because we want it moles per DM minus cube times by 1.0. And in this case, it's going to be 20 divided by 1,000 times by 2.0. Now, once I calculate those values, so I get 0.03 moles, and in this case, 20 divided by 1,000 times by 2.0, 0.04. Now, if we read carefully what the question says, it says line X shows how the volume of the 0.031. So line X, you can see it, plateaus, and it's the exact same as C here. So it's right here, and this is 0.03 moles. Which line shows how the volume of hydrogen produced changes with time? This case, well, it's going to be the one 0.04 moles, right? And we can clearly see that it's going up by 0.01 moles, 0.01, 0.02, 0.03, and therefore that will be 0.04, and therefore the answer is B. And now to mark it, question 1B, question 2D, oh, okay, got question 2D, I got question 2 wrong, 4B, 5C, 8C, 15B, yeah, so I got question 2 wrong. So let's have a look at question 2. The more molecules, the most probable energy. Yeah, that is incorrect. The increase in the most probable energy of the molecules. Yeah, because we're increasing the temperature, so the most common energy, most probable energy, probable meaning the probability of happening is most common, it will be an increase. So the answer is in fact D, not C. Question 2D. And that's it for today's video.